Hi class, in this assignment we're going to look at claims about proportions, which is pretty much percentages like we did earlier for the confidence intervals. So whenever they give us some sort of a proportion, they're talking about a percentage. And then these are the main requirements. So all of these are going to be binomial problems that pretty much look bell shaped. So they're going to look like that. And then we're going to be assuming that, well, in this case, requirement 1, 2, and 3 are satisfied. Next order of business is the regions. Now, we're going to have the same ideas. And let me just move on to the actual hypotheses. So if there is a claim that, in this case, a percentage is less than a value, then you're going to be looking at this region. If the claim happens to be of equality, so these are going to match for the equals. They're going to match the same regions that we had for confidence intervals. And then you could also have the idea that the claim happens to be greater. So any claim that happens to be greater, it's going to be in this sort of a format. For the region, your critical value is going to be on the right. Claim of less, your critical value is going to be on the left. And a claim of equals, well, you're going to end up with two critical values. The important part for this assignment, it's going to be the actual test statistic for proportions. That's going to be the test statistic. And remember that, well, your p hat represents x over n, and these represent successes among the n trials or whatever they're asking for in that specific problem. Let me actually move on to example 1. Oh, and then the last portion is if the hypothesis test doesn't tell you the level, you're going to be using the default value of 0.5. Okay, take a second and take a look at example 1. And we're going to follow the same procedure that we did earlier for the actual means. And this is going to be first to look at the claim. So in this case, I'm going to look at the claim. And the claim says, well, the proportion of the blue M&Ms is 30%. So I'm just going to say that P is equal to 30% or 0.30. And we're actually referring specifically to the blue M&Ms. And this is just to clarify what's actually going to be your X's. Next order of business is going to be the hypotheses. So let me just rewrite it as state HO and the values of H1 or of H8. Because the claim is an equality, we're going to be looking at the two-tailed test. So I'm just going to say that the values of HO, and remember that HO is always equals. So it's going to say P is equal to 30%. And HA or H1, well, this one's going to have P is not equal to 30%. And we're looking at, well, technically, notice that all of the HOs maintain equality. Is the H1 or HA the alternative hypothesis that changes? So at this point, we have the first two steps, which is the claim, state HO and HA. The next step is to look at the population. So for this, we're going to be looking at the critical values. Now, for the critical values, we're going to be looking at alpha, which is equal to, and in this case, it's given as 0.10. And that means that your values of C is equal to 0.90. So this is one of the standard values, but let me just construct it since some of these may not be standard. And in this case, we're going to have a C value here, another C value on the right. And if alpha is equal to 0.10, that means that alpha divided by 2 is 0.05. So this is going to be 0.05. This is 0.90, and this is 0.05. In order to get the calculator value or code, it's going to be the inverse norm of 0.05. Remember that all of these are going to actually be z-scores for proportions. And in this case, this is going to be a z-score. That's the test statistic, but it ends up being the same idea. So please evaluate that in your calculator. Let me display the calculator. And in this case, we're just going to do an inverse norm of 0.05. And this is one of the standard ones. So we're looking at negative 1.645. So this is going to give us approximately negative 1.645, which means that this value here is 1.645, and this value here is negative 1.645. Let me just write it out as the critical values are C is equal to plus or minus 1.645. And this is one of the ones that was actually in the chart for the previous handouts. The two-tailed tests are going to match to the confidence intervals that we did in a previous assignment. Okay, now that we took a look at the population, the next step is to actually look at the sample. And what we're trying to see here is if based on this sample, do we have sufficient evidence that the proportion of the M&Ms that are happen to be blue in this case happens to be 30% based on the sample. Now, as we look at the sample, now we're looking at the test statistic. And the basic idea is if your test statistic falls under the red, you reject HO. And if not, you fail to reject HO. A fail to reject HO means that there's not sufficient evidence to get rid of this one. Then the other one is technically correct. But before we do that analysis, let me actually jump into the test statistic. So in this case, we're going to evaluate that z-score. So as we look at the test statistic, we're looking at the sample. So our test statistic is equal to p hat, and then we have the minus the values of p over the square root of p and q over the values of n. We're going to be carrying about 4 decimal places, so your p hat is equal to x over n, and the x happens to be the total number of the blue M&M, so in this case 14. So let me just write it out as n is equal to 57 and x is equal to 14, or 14 over 57. These end up being 0.2456. And that's actually it. Oh, okay, so P is equal to 0.30, which gives us Q is equal to 0.70. P and Q are complements, same idea for P hat and Q hat. So the main formula for Q is equal to 1 minus P. Okay, so let me punch in the values. So in this case, C is equal to 0.2456 minus 0.30 over the square root of 0.30 times 0.70 over the values of 57. And let me double check 57. Okay, take a second and punch it in. Okay, please check if you're getting, and 2 decimal places will be sufficient, negative 0.808962, which I'm just going to round to technically negative 0.90. So negative 0.90 happens to be our test statistic, and now we're going to be looking at the position of the test statistic. Remember that this is 0 on the Z-score scale. If your test statistic falls under the red, you reject HO. If it falls below, your conclusion is going to be fail to reject HO. So let me just write the conclusion. In this case, fail to reject HO. We can state that since the test statistic of C is approximately 0.90 is in between the critical values of C is equal to plus and minus 1.645. Now let's do a basic analysis of what this means. So since we ended up with the test statistic in between these two, that means that you failed to reject HO. That's this one. That means that there is not sufficient evidence that P is not equal to 30%. And some of the problems may ask you to basically write that out, and let me write it out. In this case, there is not sufficient evidence with alpha is equal to 0.10 to conclude that P is not equal to 0.30 for the blue eminence. And for most of the problems, it's going to be sufficient just to say fail to reject HO, since the critical values are outside, or your test statistic is not in between, it's not outside on the red region. Other problems are going to want the official wording. I'll go over the official wording during the actual meeting, but that's actually it for this one. So this one, it would have been perfectly fine if it's not asking for the anything else regarding the conclusion, to stop here. So it would have been fine to say fail to reject HO since the test statistic of C is equal to 0.90 is in between the critical value of C is equal to 1.645. That's perfectly fine. And that's actually it for this one.